we're going to talk about 4, which is parallel and perpendicular lines. We're talking about the first half, so we're just looking at parallel lines. So parallel lines are lines in the same plane, so that means like they're all on the same flat surface that do not intersect. Okay, this is the big part about parallel lines, is they do not intersect. They can run right next to each other and never touch, ever, at all. Not in a million years, no matter how far you go out, whether you go if you go this way or you look this way, those lines are never going to intersect. They are called parallel lines. These lines, parallel lines, they have the same exact slope. And that's going to be really the big key thing for finding parallel lines. We're going to jump right into some examples. Okay, so we are going to, I'm going to try to just type this, okay? Let's see. Write an equation in slope intercept form for the line that passes through -3, 5, and is parallel to the graph y equals 2x minus 4. Alright, so what we have here is we need to write an equation in slope-intercept form. So let's remind yourself what slope-intercept form is. The slope-intercept form is y equals mx plus b. Okay? And we needed to go through the point -3, 5. And it needs to be parallel to this line here. All right, well, we said parallel lines have the same slope. So what we'll do, the line that needs to be parallel to it has to have the same slope as that line. Well, that line has a slope of 2, right? M equals 2 in this equation. So we know our equation we need to write, M is going to be 2. All right, so now we have slope. Okay, we have a point. How do we write slope-intercept form from this? So this is actually coming back from 4-2, where we are given slope and a point and we need to solve. So what we're going to do is, to start, we have our slope. Okay, we need our y-intercept to finish writing this in slope-intercept form. To get our y-intercept, what we're going to do is use our point here, right? Every point is an xy pair. So we're going to put our x in this equation as -3 and our y as 5. Okay, because this point is on the graph of the line that we want. So that means that this point is a solution. We can put x for -3 and y for 5, and we will get something that's true in the end. So what we'll do is we'll set y equal to 5 and x equal to -3. And now we have one variable, b, and we can solve for that variable. So 2 times -3 is -6. I add 6 to both sides, and I get 11 equals b. So my y-intercept is b. My slope is 2. So to write this in slope-intercept form, y equals 2x plus 11. Okay? We can now, hold on a second. Let's do another one really quickly. Alright, so let's write an equation of a line parallel to y equals 1/4 x plus 7 that goes through 4, -1. Right, So to do that, okay, we need to write this. Let's write it in slope-intercept form. I didn't specify, but let's write it in this form. Okay, it's going through this point 4, -1. It needs to be parallel to this line. Well, if it's parallel, it's going to have the same slope. So it has a slope of 1/4. Okay, so we have the slope of our line. We have a point that's on that line. This is, again, is going back to 4, 2 when we're given a point and our slope. So what we can then do is, another way we can do this, instead of doing what we just did before, why don't we use point slope form, right? Because we have a point, we have a slope. So let's write this in point slope form. So that form is y minus y sub 1 equals m times x minus x sub 1. Okay, so our x sub 1 and our y sub 1 is the point that we're given. Okay, so x sub 1, y sub 1. So if we start writing this, our y sub 1 is our y value in our point, which is -1. We said our slope is 1/4. And our x sub 1 is 4. Alright, so now we're going to simplify this and solve for y, because getting an equation in slope-intercept form, we have it solved for y. Okay, so y minus -1 is y plus 1. Okay, and then over here I'm going to distribute, and I have 1/4 times x, and then I have 1/4 times -4, so that'd be -1. And now I just need to get this plus 1 on the other side, so I will subtract 1, and I have y equals 1/4 x minus 2. And that is my equation in slope-intercept form. That is parallel to this y, to this y minus, or y equals 1/4 x plus 7. They have the same slope. The only thing that's different is the y-intercepts. Alright, so that's pretty much the gist of parallel lines.